Geometry lesson 2-5, continuing on with more information about proofs and theorems, and to help us set up two-column proofs, we have the idea of a theorem, which is a true statement that follows as a result of other true statements. So the creation of the theorem comes as a result of finding and proving that other things are true. So it's a process. A two-column proof, just similar to the ones that I used as an example last time, are numbered statements and reasons that show the logical order of your argument. So we would have, for example, one of the most popular is the beginning one with a given. We'd have something that was given to us, and the reason we've implemented that into our proof is it was a given information. From there, we take that information and we can continue to build off of it. And one more property to give you, so you can use as a tool in one of your proofs or theorems, is the property of segment congruence. Remember that segments have a start and a finish, and congruence means exactly the same size, shape, everything about it. In order for segment congruence, right, segment congruency is reflexive. That means that if you have two segments that are the same, that's the reflexive piece. They're exactly the same. They're symmetrical. They can be flipped, and they're transitive. If you know one is congruent to another, and that one is congruent to a third, then the first and the third are going to be exactly the same as each other. So I'm going to give you a couple more examples for two-column proofs. Say we have given that the distance from E to F is equal to the line, the distance from G to H. Can we prove that line segment EG is equal to FH? So here's the given situation. This is actually very similar to the last proof that we did, where we were using the distance from here to here and the distance from here to here to prove that these two were the same. Now it's the other way, and we're saying that EF, which is here, is congruent to GH here. Can we then prove that E to G is the same as F to H? So it's just the other way of what we were doing last time. So a two-column proof, we'll have our statements, and then over here in parentheses I'll put the reasons. So our first statement probably is going to deal with something that we have given to us. So we have a starting point in the problem, and we would say that EF is equal to GH. So EF is equal to GH because of the given information. It gives us a starting point. Then, from there, we will say that EF plus FG. Now, EF plus FG, that's the middle portion. And GH plus FG. In other words, both sides of this equation have F to G added to it. And if you add the exact same thing to both sides, then it's the addition postulate, or the addition property of equality. So we added the same amount to both sides. Now if you take EF and you add FG to it, you're going to have another segment. So you'll notice there's the part I underlined, is right here. So there is the part we had before, and now it's equal to EG. And anytime you take one chunk and add it to a second chunk to make a longer piece, that's going to be your segment addition postulate. You'll notice here's that part here and here, saying that this piece plus this middle piece will equal the entire segment H to F, or F to H, either way. So that's the same piece. We now know that we're dealing with the whole segments that I labeled as the blue and the green. Alright? Now, EG and FH is substitution. Let's think about where this comes from. Here's the EG, which is the same. Okay? So that's staying here. Here's the FH, which is here. But the reason we're able to stick FH in for all of this is because FH equals the GH, and the GH plus FG is equal to this. So because those two are the same, and that's really this, and I know that this is the same as here, and those two values are exactly the same. So it's substitution. It takes a little bit. Imagine if this were 5 inches, then this would have to be 5 inches over here. If that's 5 inches, it's the exact same value as this being 5 inches. And if all of this is 5 inches, then EF plus FG is 5 inches, which means that right here is going to be 5 inches, which would then make EG 5 inches. So if you wanted to, you could say these are equal, which means that's the same thing, which means these are equal, which then tells us that's the same, which means that's the same. So that's kind of the flow, and we're substituting those values in. Okay? And the last thing we would say is, since they are exactly the same length, then the line segment from E to G is congruent to the line segment F to H, which is what we were trying to prove. So we have it. So again, proving, taking something we're given, we're adding the exact same thing to both sides. That's the addition postulate. Same value was added to both of those pieces. That told us we had a chunk in here, chunk right there, for segment addition postulate. Now we know that if those two values are the same, then they're interchangeable. If I wanted to, I could put GH right here and FG is over here. I could put that value right there as well and say that's EG. So there's a lot of substitution you could use. All right, one more dealing with line segments. We now know that we have X as the midpoint. So what do we think about midpoint? Midpoint means like middle. And if it's in the middle, then both the sides have to be equal. It is the midpoint of M to N. We also know that M to X and R to X are exactly the same value. We are trying to prove that from X to N is the same as R to X. So here's the diagram. And let's look at it in terms of what's been given to us. If we know that X is the midpoint of M to N, if we know that, then that means these two values have to be exactly the same length. We also know that MX, which is here, is exactly the same as RX. That's been given to us. So we know these two values are the same. We know that that's the midpoints of those two. We are trying to prove that XN, which is here, is exactly the same as RX here. Now we already just talked about how the fact that that's the midpoint, so those two are the same, and then these two are the same because that's given. But we've got to be able to give it a logical argument. So of course we'll start with statements and reasons. And our first one is X is the midpoint of MN, which is given. We know that. What does that tell us? Now that we know that that is the midpoint, we know that XN, which is from here to here, and from MX, which is here to here, are going to be equal to each other. And we know that because the definition of a midpoint tells us when it's in the middle, both sides are exactly the same length. Okay, so we're on our way. Next, we take some more given information. The fact that MX and RX are the same. That was given. Next, we substitute. Now think about this. If XN is MX and MX is RX, then we should be able to kind of, in a way, cancel these two out and say XN is RX. Oh, XN is RX. That's the transitive property. Just like I'm older than Sue, Sue is older than Ben, so therefore I'm older than Ben. Same idea, transitive, which was a property that I gave you for segment congruence. Segments are transitive. If one line is congruent to this line, and this line is congruent to this line, then this line is congruent to that third one as well. That's the transitive property for a segment. So we've done what we wanted to do. We've succeeded in stating that XN is the same as RX.